The n-queens problem, LeetCode 51. We get as an input an integer n, and we need to place n queens on an n by n board. The board has n square cells, n by n. We need to return a string, and a q on a cell would mean that we have decided to place there a queen, and a dot would mean that we have there an empty cell, meaning we do not place there a queen. Let's remember that queens on a chessboard can move horizontally up and down and on a positive and a negative diagonal. Now to the solution of this problem. Let's first understand that each queen must be on a single row. We cannot have multiple queens on a single row because then they would collide. We cannot have multiple queens on the same column, and we cannot have multiple queens on the same diagonal, either positive or negative diagonal, because then they would collide. So apart from the actual solution, we want to store a state. This state would be multiple sets, a set of the columns that already have queens, simply integers. If we place the queen on column number 3, then we would store column 3, the number 3, in this set. If we also have a queen on column number 5, then we would store 5. And also we would have two other separate sets. One set would store the positive diagonal and another set would store the negative diagonal. Now you may ask, why do we not need to store a set of the rows? This is because we simply loop over the rows. So once we finished with row number 1, we loop to row number 2. So we don't need to remember in a set that we don't need to place a queen on row number 1 because we already finished and our loop continues. Now the question is how to mark on these sets that store whether a queen is in this positive or negative diagonal. Then there is a trick, because if we place a queen on row number 2, column number 3, then the positive diagonal would be row minus column. So each and every cell that would correspond to the same row number minus column, this would be on the same diagonal, because when we move on the diagonal, we move to the bottom one row, so we add one row, and we move to the right, so we add a column. And on the other side, on the other diagonal, we move down, let's say one place, and we move to the left. Okay, so the positive diagonal is row minus col, and the negative diagonal is a constant row plus col. And then we do the solution. So this is a solution where we need to place a queen, let's say on row number 1, and then we move to row number 2, and then we need to decide on which column to place the next queen. And if we can't place the next queen on a certain column, then we need to move backward if we don't have solution. If we don't have any column to place the queen, we need to move backward. This means that we are going to use backtracking. In the backtracking function, we have 3 major components. The first item is to check whether it's a recursion, to check whether we reach the end game. What is the end game? We have a solution. So first we check if the parameter to the backtrack would be the current row to place the queen set. If the current row to place the queen set is equal to n, which means we finished, then return the board, return the current solution. Add the current board to the solution, to the list of solutions, and return it. Otherwise, we didn't reach the end game. We still have rows to fill in. Therefore, let's move on to the next column. Let's scan all the columns and try to fit in a queen. This is backtracking. We try to fit in a queen into a column. If we can fit a queen into a column, meaning we don't have anything in the set of the cols or the set of the diagonal, then we update the sets because we have placed a new queen. So we update the set of the cols that we already have their queen. We update the sets of the diagonal, the positive and negative diagonal, and we mark the cell with a Q. Then we call backtrack to row plus 1. Let's backtrack and try to fit in a queen to the next row. Once we finish, the interesting thing is that backtracking, once we finished with the next row, what we actually do is remove from the sets, because when we finish with the backtracking, we call backtrack for row plus 1. Okay, and then recursively we call in and in and in. When we would exit into the next line, either we successfully found the solution, in which case we want to find the next solution. In order to find the next solution, let's backtrack and go to the sets, same sets that we added queens, and mark them, remove it from them, and continue to the next column. We are inside the loop of the columns. Or we couldn't fit in a queen. Okay, so let's remove the last queen that we added to the columns and to the diagonal, mark it with the dot, and continue in the loop of fitting in queens. So this was LeetCode 51, fitting queens into n by n board.